Hey, this is Michael. I'm going to take you through a tutorial on how to create a symbol for a large component like an FPGA using a technique that I've been refining for a few years. It actually started with OrCAD years ago. I start the process by grabbing the pin list from the FPGA vendor. So I've already done a little search here to find the pin list for the Xilinx AMD FPGAs. Here's the pin list files for the Altera Intel FPGAs. I wasn't able to find a single website for Lattice Semiconductor that pointed to all their pin lists, but I did find some of them. Likewise from Microsemi, I wasn't able to drill down and find one web page on their site that had a link to everything, but I did find a few. So let's go ahead and grab a pin list for a Spartan 7. That's a pretty small and easy FPGA to work with. I've done this for very large Vertex ultra-scale FPGAs, but it actually took me days to create the symbol for that. Let's go ahead and do this for, say, an XC7S25 and the CSGA 225 package. Now here's the pin list. It's just a text file, and it has the pin number. This is a BGA package, and the pin name, and a whole bunch of information that we don't really need for generating the symbol in our schematic tool. So what I'm going to do is I'm going to save this file. Actually, I've already saved it, and we'll go ahead and grab it, open it up here. Oh, I did. Yeah, there it is right there. I'll open it up in my favorite text editor, which is Notepad++. And what I'm going to do is I'm going to cheat a little here. Since I'm going to open it up in Excel and add a few more columns. And when I open it, I'm going to select space as a separator. I'm going to go ahead and add an underscore here so pin name stays associated with this column. I don't care what happens to the rest. I'll go ahead and save that, close that. Then I'm going to go ahead and open up Excel. And I'm going to open up that file, browse, go into my projects folder, my YouTube tutorials, select text file. There you are. And I'm going to open up that pin list that I just pulled down from the Xilinx website. And it's delimited. It's delimited by spaces, and done. And what we have is the header, which we'll delete. And then we have columns with the pin number and pin name, which is what we want. I'm going to go ahead and delete these first, this header here, right up to the header for the pin list. Delete. And I'm going to go ahead and delete these columns that we don't really need. And what we're left with is the pin number and the pin name. Perfect. Now I need to add a few more columns. Altium wants an electrical type, and they want to know what side the pin is on, top, bottom, right, or left. And I'm also going to add a part column. And this is what I'm going to use to separate the pins into parts. This first group of pins here with the underscore 0, these are all in IO bank 0, which is the configuration bank for these Spartan FPGAs. I'm going to start by setting the type to passive. and the side to right for every pin on the part. And I'll go ahead and just do a fill down, a Control D, put that information in for all 225 pins, get rid of the stuff at the bottom, and then let's shoot back up to the top. What I'll do is I'll put all the configuration pins in part A. So I'll just do a fill down for all the pins that end in _0. Then I'm going to put every pin in bank 14 in part B. And I'll do the same there, do a fill down with the B for every pin that ends in _14. And I'm going to put all the pins in bank 15 in part C, and all the pins in bank 34 in part D, and I'm going to take all the VCC and ground pins and put them in part E, with some exceptions. I like to put the VCCO pins for the I/O banks on the same part as the I/O bank itself. So bank 0 is part A, so I'm going to put the two VCCO pins bank 0 in part A, VCCO 14 in part B, VCCO 15 in part C, and 34 in part D. I'll go ahead and save that. Save as. Let's remember to save that as an XLSX saved. Alright, let's shoot back up to the top. Now what I like to do is I like to put all, evenly distribute the pins on the right and left side for each of the I/O banks. I won't do that for bank 0 just yet, but bank 14 is, like many of the Xilinx FPGAs, is composed of 24 differential pairs. So I'm going to put differential pairs lane 1 through lane 12 on the left side. I'll also grab this guy as well. Right down to 12N. And then I'll leave lane 13 through 24 plus this oddball on the right side. Do the same for bank 15. Put lanes 1 through 12 on the left. And leave 13 through 24 on the right. Bank 34. Same thing all the way up to 12N here. Down. Oh, must have blown that. Try that again. Filled down. Oh. And I don't know what I'm doing. LEFT and Control D. I must have hit something other than Control D. There we go. Filled down. And what do we got left here? Alright, I like to see my VCCs on the top. So I'm going to type top and do a fill down wherever I see a VCC. Control D. Some more VCCs. I'll put them on top. Fill down. And I like my grounds to be on the bottom. BOTTOM, and fill down wherever I see a ground, and down. So I think I've got everything done. It's a small part, so it goes fairly quickly. I'll go ahead and I'll put the JTAG signals, TCK, TMS, and so forth. I'm going to put them on the left, just because I know how I like to see this I/O bank arranged. Configuration clock I'm going to put on the left. The mode pins I'll put on the left. Come on. TMS, program, mode, TDO, TDI. I'll throw a nit B out there. What have we got left? Those can stay on the right. Okay, and we'll save that. So now we're ready to sort. So I want all the pins associated with part A all grouped together so I can quickly grab, copy and paste them when it comes time to go into Altium and use the symbol wizard. So I'm going to go ahead and do a Control Shift down arrow, select everything, move over here, do a custom sort. We're going to sort by column E, which is where the part is. Okay, and what that did is it moved the two VCC0 pins up into the group of A pins and so forth. Same with the B, same with the C. Okay, so we're good. And now we're ready to move into Altium and make use of the symbol wizard. So I've already opened up a library. We have a library open where we want that part to reside. And with that library open, I can go into the Tools menu, select the symbol wizard. I'll start by clearing out the default data. And then I'm going to go ahead and copy the information for part A right there. I don't need the part column, I just need the pin, the name, type, and side column. So Control C to copy that. And then I'm going to right mouse click, Smart Paste. Now initially, the symbol wizard doesn't know what's in each column of data I've just pasted in, so I'm going to tell it with this little drop down menu here. So the first column is the designator, the second column is the display name, the third column is the electrical type, and fourth column is the side. I'll click on paste, and there's my symbol, and I'm going to do a place new symbol. So I only do that on the first part of a new symbol I'm creating. And there it is. It gets a nice default name of component 1, and we'll move on and add the remaining parts. So we'll go back in Tools, Symbol Wizard. I'm going to clear this state out with the right mouse click clear. I'm going to copy the information for part B. There it is. Copy with Control C. Back to the symbol wizard. Right mouse click Smart Paste. All the information's there. It remembered the column names. I don't have to select them. Paste, and there's my symbol for part B. Now this time I'm going to do a place new part, not new symbol. And you notice that there's now a part B associated with component 1. And I'm going to repeat that for the remaining 3 parts. Tools, Symbol Wizard, clear, copy the information for part C, smart paste, paste, place, new part. Again, symbol wizard, clear, yes, copy, part D. And this takes a little bit of focus, and you might make a few mistakes the first few times you do it, but after a while, get the hang of it. Don't make as many mistakes. New part. And finally, part E. So tools, symbol wizard, clear, copy, part E, which is our VCC and ground pins. Copy, right mouse click smart paste, paste, place, new part, and there we go. We have part A, B, C, D, and E, 5 parts. But wait, our work is not done. So one of the things that Altium likes to do is place things off grid and so forth, which is really annoying. We're on a 100 mil grid, but if you zoom in, you can see it's not on the 100 mil grid. So I'm just going to go ahead. Let's start with part A. And I'm just going to go ahead and grab that whole thing. And I'm going to go to Edit, Align, Align to Grid, and see if that helps. A little bit. Put the pins on grid. Let's move the... I'm going to take this whole symbol and put it where I like to put it, which is the upper left corner, right at the kind of the origin there. And that's not too bad. I'll go ahead and move things around a little bit. This isn't final, but it's closer to the final product. I won't bore you to death with every step in the process. Alright, so done with that. Same thing here. I can just do a Control A to select everything. Edit, Align, Align to Grid. I'm going to grab everything again, drop it down there, tweak the symbol body. I'm going to pull this guy in. I like to see it about 300 mils wide. So I'm just going to do that. And I know what I'm going to do with this later, so I'm going to bring that down. Bring that over for now. We'll come back to this. Save that. Same with C. Control A to select everything. Align. Align to grid. I suppose I could just Control A that too. Okay. Close enough for now. Well, yeah, let's go ahead and do the bring that down. Bring these pins over to 300 mil width. I like to make the I/O banks a consistent width and height and so forth. Part D, Control A, Edit, Align, Align to Grid. Suppose I could use the shortcut there. And we'll pull that down. Grab these guys, pull them over to the 300 mil line there. Got that. I'll center these now. And save. And finally part E. Same deal. Control A, Edit, Align, Align to Grid. Ooh, that was a big shift. Okay, and I'll bring these down. I give these guys a little bit of separation. Nope, didn't grab. Separate the VCC ints from the VCC aux and so forth. This allows good visuals, and what's what. Let me just bring this down one more grid space, another 100 mils. That's not too bad. Okay, so let's go back up to part B. What I like to do with these I/O banks that are composed of differential pairs is arrange the pins in groups of differential pairs. So lane 1, P and N, P on top, N below. Lane 2, so we've got a space between these two, and there's my lane 2, and so forth. And I'll just go ahead and arrange all the pins just like that. Didn't quite make that, but that's there. There's lane 4 and 5, and it just makes it really easy to see those differential pairs. You know, even if you're not using them as differential pairs, it just makes for a cleaner look. So I've got lane 1 through 12 neatly divided into differential pairs. Now I can bring my, like to leave 200 mils from the bottom pin to the bottom of the symbol and so forth. And I could continue on doing this side. It's a little more work here because you can see the P and N are reversed. But in the end, we end up with identical looking symbols for the I/O banks. The bank 14, bank 15, bank 34 should all look identical. Same height, width, and relative pin locations and so forth. Okay. Let's work on the properties here. So we have a default name or design ID of component 1. Well, we probably don't want that. What I like to do is if it's an integrated circuit, I preface it with IC underscore, and then I go up to one of the distributors. Let's do DigiKey in this case, if we can find it. There we go. And I've already found it. And what I do is I copy the manufacturer product number. Exactly. Copy and paste. And I put that in. Paste. Designator for ICs, it's U and then question mark. I don't use the comment field. I delete that and I turn off its visibility. For description, I go back to that manufacturer or distributor website and I just copy the detailed description. Copy. We can paste that in. Alright, now then I add 2 parameters. Every company's different. But this is how I generate the BOM. I add manufacturer. And I'm sorry, Xilinx is still Xilinx. I know they're owned by AMD. And I add part number. P-A-R-T space M-E-N-D-E-R. And that part number, since I've just copied and pasted it somewhere. Oh, I did not. That's right. I'm going to go grab it from up here. Copy and paste. And I'll go ahead and add the supplier link. It's easy and it's kind of a double check on the part number, depending on what you're doing. Oh, you know, there's only one supplier. That's Newark. I'll take it. Done. I'm sure it's at DigiKey because we just saw it there, but this is what Altium found and gave us. So I'll take it. I like that part number to show up in the schematic. So I'm just going to turn on the visibility for that. And I'm going to arrange this reference designator. I'm going to put that in the upper right corner, and I'm going to move that part number down right there at the bottom left corner. Sorry, upper left corner that would be. And I'll save that. Let's just go check Where did our part go? It's down here. Let's just go check. So our reference designator ended up there. Good. Good. Not too bad. Not too bad. Not too bad. Okay. We'll go ahead and save that. So we're most of the way along. I'll show you what I do with the configuration bank. I've got a schematic page here. And here's what the symbol for the bank eventually ends up looking like, right? Nicely, evenly spaced, differential pairs, lane 1 through 12, 13 through 24, those odd balls, the VCC I/O pins at the top, and so forth. So, but for the configuration bank, depending on what configuration mode I'm using, I'll go ahead and modify it. And what you see here are a bunch of pins from bank 14 that I pulled in because I'm using the master serial mode of configuration, where the FPGA configures itself from a QSPI flash. So in this case, it configures itself 4 bits at a time from a standard SPI flash. And I organize these pins so that we don't have any crossovers. I do the same with the JTAG pins. You can see TMS, TCK. They're in the same order as they appear on the header, the standard 2x7 50 mil pitch header that's used by the Xilinx programming dongle. I just organize them there so it's a straight shot over to the pins on the header. I organize this and the QSPI flash so it's a straight shot for the various signals that go to the flash. Mode pins, I typically just put them up in the corners you see here. And depending on the FPGA, there'll be fewer or more, actually probably not fewer because this is a small one, but there'll be more pins in this configuration bank, especially if it's got an internal ADC. This is a rather small part right here that doesn't. There's my the bank for the power. I'll go ahead. I've got enough room here to actually put in the bypass capacitors right there, so that I don't have to guess what goes where. All my ground connections, my no connects. This is actually a different FPGA. This is the 7S6 instead of the 25. All right, so this works for most manufacturers' devices. I've done it with the a Max 10 device. It's a little more challenging. We do have, the pin number, but getting the pin name, it's kind of spread across multiple columns here. Lattice, this wasn't too bad. We have a pin number, but it's we have to figure out what package we're in and delete the columns that don't pertain to us. But it does have a reasonable pin name that we can use, maybe not here, and a pin number. And I didn't really look into this one. Let's see. This is from Microsemi. Does have a pin number, does have a pin name, so we could probably turn this into the put this in the same format as the spreadsheet I just showed you to quickly create a symbol for this FPGA. Doesn't look too bad. All right, that's it. Good luck and happy symbol creating.